Now, speaking of results, we promised we'd be engineering the next generation of the light device that is necessary to pass that energy to the gold nanorods, activating them, generating heat from the inside out. Len, do you want to take us through the work we've done with Minnetronix, who, by the way, are coming in now ahead of schedule and ahead of budget, I'm pleased to say.
Sure, it's been a great project. So the goal of this project was to develop a next generation light device that can port light through a long fiber that passes through the channel, the tool channel in an existing endoscope. And that's how we're going to deliver light inside the GI tract, the lower GI tract of humans. And the concept, I think you can see here, there's a console, there's a fiber that comes out of it, it passes through a scope, it goes into the patient where it needs to go, and then the physician can both see where they are and navigate around, they can visualize tumors, and then they can press that foot pedal you see on the left, and they can essentially zap the tumor, they can treat the tumor with infrared light for the desired period. And another component of this that we're enabling now is to be able to monitor the temperature while they're doing that. So they can say, okay, I need to get up to my target temperature and I need to hold it there for a few minutes, and then we can move on to the next tumor. So it's really a very elegant approach that uses a key tool, the endoscope, that the physicians use every day. And so I think that's an important part of it. It's going to require minimal additional training. Now, here's the endoscope we had delivered recently from Fuji. We started a collaboration with Fuji to develop this system, and they've been very supportive of what we're doing. Then there's another picture of the end of the endoscope, if you will. That's the business end of it. There are two darker holes there. Those are the working channels in the scope. One's 2+ millimeters diameter, the other is 3+ millimeters in diameter. And so those are plenty big enough to put fibers through. We've already got our fiber running through that channel and the ability to deliver infrared light. And so it's going to be a really nice system, I think. And again, this is an off-the-shelf endoscope.
Len, what are these other components here? A highly functional device, it would seem.
Yeah, well, the two, so down here, where that's the camera in the middle. The two on either side of it are the lights, LED lights. The one on the top, I believe on this scope, is another camera for a different imaging mode.
I wonder if it was that or a snare.
A snare goes through one of the working channels.
Oh, does it? Okay.
Yeah.
Interesting. Okay. So, highly functional tools here that we're going to be leveraging for our light device. And here's just one more picture of it in action, Len.
This is another one of these simulated tumor models. Again, a 1 centimeter meatball, if you will, simulated tumor with nanorods in it. Now, that orange fiber you see at the top is the fiber carrying the infrared light. The yellow fiber you see coming down is a non-contact infrared thermocouple to measure temperature. And then those two little needles you see in the side are, this is primarily for mouse studies, bench studies, preclinical studies, that these are little needle thermocouples that can be inserted into the tissue and give you a very rapid, very precise temperature measurement. So one of the things we've got to do, of course, is make sure the calibration of the non-contact sensor is right, and we can monitor tumor temperature at multiple depths and under multiple conditions and so forth, and make sure that we're getting accurate temperature readings through the non-contact device.
And in fact, yeah, go ahead, please.
Okay. This is an example of maintaining temperature. This shows temperatures from 3 different thermocouples here, and you can see that sawtooth curve is holding temperature around the target. Now, this was the very, very first time we did it with this new device. It's only gotten better and will continue to get better, but learning how to use the device, this was the very first time, which is pretty good. So we're at the target temperature plus or minus about 3 degrees Celsius, which is certainly within the range we want to be. It's not getting anywhere close to ablation temperature. This is going to get better and better. And the next step we're working on is an automated feedback loop to essentially run the system. And the user, the doc, will say, here's the temperature I want, make it happen, make it hold it there.
But this again comes back to this concept that the work we're doing is the logistical elements of putting together this therapy. And there's a lot that needs to be understood and done in that realm here. And here you can see, just to be clear, the 3 lines each relate to one of those temperature probes we saw on the previous page. Our software enables us to use up to 8 different inputs on temperature, which could be important as well.